Hey guys, it's Miss Johnson. I'm here to bring you our Unit 9 Note 6, where we are dividing a polynomial by a monomial. So this continues our discussion of rational expressions, where we've got a big long polynomial on the top and one term on the bottom, and we're going to talk about how to simplify those expressions. So we're going to start off by just revisiting some long division. We're going to need this concept when we go into some more division later in this unit, but we're just going to review it today. If I wanted to use long division to calculate this product, basically doing this without the use of a calculator, I take my dividend on the top and I put my divisor on the bottom, on the outside. So dividend on the inside, divisor on the outside. Set up your little division box. And then you need to ask yourself, how many times does 15 go into 32? 15 won't go into 3, so I have to skip that decimal place. Then I go over to the 32. 15 into 32 goes 2 times, and 2 times 15 gives me 30. Multiply those, and then subtract. 32 minus 30 is 2. Bring the 4 down and do it again. 15 into 24 goes only 1 time. 1 times 15 is 15. Subtract, and 24 minus 15 is 9, and then bring down the 0 to make it 90, and then ask yourself one more time, 15 into 90. 15 goes into 96 times. 6 times 15 is exactly 90, and I'm left with no remainder. So my division here, my quotient, is 216. In number 2, I have 5,730. And I'm dividing that by 12. So again, I start by asking myself, how many times does 12 go into 57? And 12 will go into 57 4 times, so I have a 4 up top here. 4 times 12 is 48. Subtract those two and I have a 9. Bring down your 3. 12 into 93 will go 7 times. 7 times 12 is 84. Subtract, and once again I get a 9, and then bring down the 0. 12 into 90 will go 7 times again. 7 times 12 is 84 again, and subtract those and I have a 6. So basically you have a remainder of 6, which is out of what you divided by 12, and 6 out of 12 is the same thing as a half. So my quotient here is 477 and a half. So we're going to need that review of long division when we work tomorrow on some more dividing of rational expressions. That was just us kind of revisiting something we probably haven't done in a very long time. Now let's go back to our monomials. So when we're talking about monomials and we want to divide a polynomial by a monomial, the first thing we're going to do is we're going to split the polynomial so that each term is divided by the monomial. Split it up. So you have a whole big thing on the top divided by one term on the bottom. We're going to split up those terms on the top and write the divisor underneath each one. We're going to divide out the coefficients, take out any common factors, really is what that means there. And then we're going to subtract the exponents. Take out any common factors. And then with the exponents, we subtract them. Simplify the exponents by subtracting. See where the extras are. Sometimes the extras are on the top, but sometimes they're also on the bottom. So you just have to see where the leftovers are. And then you rewrite your new polynomial separated out as separate terms. So let's give this a try. We're going to do a bunch of practice examples together. In number 3, I have 6x to the 4th minus 12x to the 3rd, all divided by x. So basically I need this term divided by x and also that term divided by x. So I'm going to split those apart. 6x to the 4th over x minus, because there was a minus between those, 12x to the 3rd, also divided by x. Every term in the top gets divided by the bottom. Now I just need to simplify each term individually. So in the first one, I have 6 divided by 1, which is still 6. And then I have x to the 4th over x to the 1st. So one of my x's is going to go away, and that's going to be x to the 3rd. The second term, I have 12 divided by 1. This coefficient is 1, and that's still just a 12. And then here I have x to the 3rd over x to the 1st, where I can get rid of 1, and it leaves me with 2. 3 minus 1 is 2. So when I rewrite this, I have 6x to the 3rd minus 12x squared. And that's my simplified expression. Let's take a look at number 4. In number 4, again, I need to divide that by the bottom and that by the bottom. So I'm going to split them apart. 16x to the 5th over 2x plus 2x squared over 2x. For the first one, 16 divided by 2 is 8. And then x to the 5th over x, that was just me taking out a common factor of 2, by the way. I divided by 2. If I divide out an x, I can make one of these x's go away, and this will be x to the 4th. So I have 8x to the 4th for that first term. Over here, 2 divided by 2 goes away, and x to the 2nd over x, this is x to the 1st, 1 can go away, and that will be x to the 1st left over. So I'm really left with just x. You could call it 1x to the 1st, but you don't, the 1's are redundant. The 1 coefficient and the 1 exponent is redundant. You don't need it. Let's keep going. Let's take a look at number 5. In number 5, I have 3 terms in the top now. So all 3 of these, this one, and that one, get divided by the 6a. So 12a to the 5th over 6a minus 3a squared over 6a plus 42a over 6a. And all of those need to get divided. So let's start with the first one. 12 divided by 6 is 2. A to the 5th over a to the 1st, I can subtract one of them. That leaves me with 4 left on the top. Second term, 3 over 6. Be very careful here. You can take out a common factor of 3, but you have a 1 on the top and a 2 on the bottom. So we're going to talk about what that looks like when we get our final answer here. So I took out the common factor of 3. 3 out of 6 is basically the same thing as 1/2. So I have 1 over 2. Then I have a squared over a to the 1st. This a goes away, and that becomes a to the 1st, because 2 minus 1 is 2. And then in the last term, 42 divided by 6 is 7, and a's cancel. So let's put together what we have left. In the first term, I have 2a to the 4th. 2a to the 4th. In the second term, I have an a on the top, and I also have a 2 on the bottom. So my 1/2, you could write this as 1a over 2 if you wanted to, but you don't need that one. But my 1/2 is a fraction. It's not 2, it's 1/2. The 3 over 6, the 6 was on the bottom, so be very careful when you write that. And then in the last one, I'm left with just a 7. And by the way, none of those are like terms because I have an a to the 4th, an a to the 1st, and a constant with no a. So I can't combine any of those. That's as simplified as it can get. Number 6, I have 15x to the 4th all over 5x minus 35x to the 3rd all over 5x plus 20x over 5x. And then I need to simplify each one individually. So 15 divided by 5 is 3. X to the 4th over x to the 1st, I can get rid of one of them, and that leaves me with x to the 3rd. Then 35 over 5 is 7. X to the 3rd over x to the 1st, I make 1 go away, and that's x squared. 20 over 5, that's a 4, and x over x's go away. So I'm left with 3x to the 3rd minus 7x squared plus 4. By the way, that whole dividing the coefficients and subtracting the exponents, that comes from that quotient of powers property that we learned way back in Unit 3. The quotient of powers property told that when we divide powers, we subtract their exponents. So that's where I'm getting those subtracted exponents of like 4 minus 1 giving me 3. Let's take a look at number 7. In number 7, I have 3 terms again on the top. So I have 2x to the 3rd over 6x on the bottom, plus 6x squared over 6x, plus 42x over 6x. So now when I simplify, again, this isn't 2/6. Think of this like a quiz score. You got 2 out of 6 correct on a quiz. This is not 3. This is 1/3. This is 1 over 3. So be very careful. Watch for where your bigger numbers are. Watch for what those fractions actually look like. X to the 3rd over x to the 1st. I make 1 disappear and I'm left with 2. Here, 6 over 6 goes away. X squared over x to the 1st is just going to be x to the 1st. 42 over 6 is 7, and the x's cancel. So I'm left with x squared over 3 in this first term. I had an x squared on the top, but I have a 3 left on the bottom. Then I have an x in the middle, then I have a 7 at the end. So that is my simplified expression. In number 8, I have 10a squared over 2a plus 6a over 2a plus 12 over 2a. Let's take a look at what happens here. 10 divided by 2 is 5, which is great. A squared over a to the first, 1 goes away, leaves me with 1 on top. 6 divided by 2 is 3, and then I have a over a, which goes away. And in the last one, 12 divided by 2 is 6, and I have an a on the bottom, but that's it. I don't have an a on the top, so I have to leave my a on the bottom because there's nothing on the top to cancel with it. So let's see what I have now. I have 5a plus a constant of 3 plus 6 divided by a at the end. That's a 6 divided by a. Hopefully you can read my handwriting there. Okay, 2 more practice examples that we're going to look at together. In number 9, I can split these off. 15x to the 4th over 5x plus 7x to the 3rd over 5x plus 10x squared over 5x. And then I go to work and simplify. 15 divided by 5 is 3. X to the 4th over x, that's going to go away, and that's x to the 3rd. 7 divided by 5, there are no common factors there. 7 and 5 is just going to have to stay how it is. But the x's, x to the 3rd over x, I can reduce that. So x to the 3rd is going to become x squared, and that x goes away. 10 divided by 5 is a 2, and then x squared over x, that goes away, and that's just x to the 1st. So I have 3x to the 3rd plus 7x squared over 5 plus 2x. And last example that we're going to do together today, 35m to the 6th over 7m plus 7m to the 4th over 7m minus 21m over 7m. And then reducing these, 35 divided by 7 is 5. M to the 6th over m, that's going to go away, and that's going to be m to the 5th. 7 over 7 is gone. 7 divided by 7 is 1. M to the 4th over m to the 1st, that goes away, and that's m to the 3rd. And then 21 divided by 7 is 3, and m over m cancels. So I have 5m to the 5th plus m to the 3rd minus 3. All right, that takes us to the end of our notes video for today. Thanks for listening, and I will see you next time.